Beth.
And I'm Beth.
Welcome to Physics with Beth and Beth. Hello, welcome to AP Physics 1 with Beth and Beth. I'm Beth. We are in AP Physics 1, Unit 6, Energy and Momentum of Rotating Systems. Today I'm going to make this video as short as I can. I think it's going to be a short one, but it's going to be really important to understand the concepts. Today, there's no math in this. We are just, no problems. We're just talking about the concept of rolling without slipping and rolling with slipping, and then sliding or skidding. These are three really important concepts, and then what's happening to your tires during that are really important concepts to understand. So we're going to try to make this short. I'm going to start right off the bat by explaining what this rolling without slipping is. So I have a surface, and I have this ball, and it's just rolling down. It's not sliding, it's not skidding, it's just rolling. Now here's the cool thing about this, and it's really hard to kind of see it at first, but this is actually static friction that is interacting between the surface and this ball. It's static friction. You're like, yeah, wait a minute, Beth. You've been telling me all year that static means at rest, and this ball is not at rest. And that is very true. But what is happening is, for a split second, every surface of the ball that comes in contact with the road is actually at rest. And it's kind of like, think of it this way, it's gripping the surface so that it'll still roll, it'll keep rolling. So every point of contact along this ball is at rest when it hits the surface, and then it grips, it kind of has a grip and then makes the ball keep rolling. Okay, that's rolling without slipping. It's static friction. An example of it would be when your tires are operating normal down the road. Every little surface of that tire, when it hits the road, is at rest as it kind of grips that road and the tire can keep rotating. Okay, and that's static friction. Now, what is skidding or sliding? Skidding or sliding is an example of that is when your tires lock up. Let's say you've slammed on your brakes, your whole car is skidding or sliding, and only one surface of your tire is in contact with the road because it's not rolling anymore. It literally is here, and you lock up your brakes, and then it just starts sliding. And that's kinetic friction, because look, if I just had an object that's not rotating, that can't rotate and slide it, we would say, hey, that's kinetic friction. All right, it's the same thing. This tire is locked up. Not every surface, when it's rolling without slipping, every surface comes in contact with it around your tire. In skidding or sliding, it's locked and it just slides across. Okay, and then that's kinetic friction. You definitely have kinetic friction there. There is no stopping this. This one surface is moving across your road. Okay, then we have rolling with slipping. That's a little trickier. It's not going to come up as much in the AP Physics 1 curriculum, but it would be similar to tires operating on a wet road, where the water is causing you to lose some static friction, where now it is like, you know, rotating, and then maybe it slides a little bit. It rotates and it slips a little bit. All right, so it's not totally just skidding across in one spot. It still is maintaining some rolling, but then it slides. Some rolling, and then it slides. So you end up with both. All right, again, it's important to understand it, but you're not gonna necessarily need to use that as much in this class. Okay, so here's what I've got. I've got three tires. Actually, it's the same tire. I'm looking at the tire as it moves linearly down the road. I'm looking at the rotational motion of the tire. I'm adding those two to come up with a total of what's happening to this tire at the surface of the road, at the axis of rotation, and at the top of the tire. All right, now remember, translational is that big fancy word for things that move in a line because there's rotating pieces. In other words, the wheels on the bus go round and round, but the bus goes down the road straight. I have this car here, and they are moving clockwise. Your wheels are going to move clockwise to get you down the road. That's why I show clockwise motion here. But as the wheels move clockwise, the whole car and all of the wheels are moving in a straight line. So you have some velocity in a straight line, and then you have this angular velocity of the wheels, okay? So this whole wheel is moving straight down the road with the car and the other wheels. All right, so we're just gonna call that a velocity T here, okay? Now, rotational, remember that velocity for rotational is r times the angular velocity. Remember that equation from Unit 5? So I have another velocity here with rotational that I need to add to this linear. When it's going clockwise, right here, it's tangent to the circle. All right, when it's up here, it's coming around and it's tangent to the circle. And I should have drawn these all equally. All of the arrows should be equal here, if I could do that, which I did not. But all of these should look equal. And then there's no velocity here at the center because remember, r is the distance from your object to the axis of rotation, or the point you're talking about, not necessarily the object, but the point you're talking about. I'm talking about the point that's on the axis of rotation. So that's just 0. So there's no velocity there in the center. And that makes sense, right? The center of the tire is not rotating. If I have this little device here and I'm rotating it clockwise, the point right here in the middle is not moving. It's all the points around that axis of rotation that are moving, that are rotating, I should say. All right, now I'm going to add these because I'm going to add these up and see what I get. Okay, at the middle, well, let's start at the bottom. I have a velocity to the east and I have a velocity that's equal to the west. So look, your velocity is 0. That's why you have static friction. Aha, it's one of those aha moments. All right, and where it just momentarily stops at that surface to grip to keep the tire rotating. Now in the middle, at the axis of rotation, I only have one velocity. I have velocity plus 0 is just the velocity. Then I go to the top. I have a velocity east and another velocity east. So up here, and I'm going to make it twice as long, is 2. So the tire is moving twice as fast on top as it is on the bottom at the surface. And it's moving 1 time as fast from the surface as it is at axis rotation. And that's because you're adding that linear to the rotational. And that's what that looks like. So I just want to make sure that you understood the difference between rolling without slipping and sliding. And then when you add these up, what your tire is really doing from a velocity standpoint at all 3 points. Now, ABS brakes, our anti-lock braking system that we have on cars now. Thank your safety auto engineers out there because they're developing these awesome things that keep us safer in our car. But what is that? Okay, your ABS brakes, what they are doing is they are taking your skidding or sliding and converting it back, and that kinetic friction, and converting it back into static friction. Why? If you remember from our friction unit, our dynamics, we said static friction is always greater than kinetic friction for one object, meaning it's easier to get an object, well, it's harder, I should say, to get an object moving because you have to overcome static friction than it is to keep it moving. Think about a big heavy box. You got to push and push, get it moving. Once you get it moving, it moves faster. For football in America, not soccer, for football, but our football, we have, when they train, they have these big pads that are on wheels and they hit them. You can always tell it's harder for them when they hit them to get them to start moving than to keep them moving when they are in their practice. All right, so static friction is greater. All right, so you're going down the road normally and you have static friction, and that's what you want. The most friction you can get, everything's happy. What if somebody, God forbid, is on their phone, they're texting, they're not paying attention, they look up and the car in front of them has just stopped for the red light, they slam on their brakes. Well, when they slam on their brakes, they lock their tires and start sliding. That's kinetic friction. It's going to be weaker. You want the strongest friction in that situation so that you can have the shortest distance of stop. Okay, you start sliding, that's kinetic friction, it's a weaker friction. It will take you a lot larger distance to stop. Whereas if you have static friction, you can stop in a shorter distance because that's a stronger friction. So what do your ABS brakes do? Well, they start pumping your brakes. That's why if you've ever had your ABS brakes go off, it feels weird. You have got your foot slammed on the brakes because that's human nature. We're like, we've got to stop. I'm slamming this brake down because it stops me. But then the ABS brakes kick in and underneath your foot, your pedal starts pumping. All right, well, what that's doing is keeping that tire rolling and not locking up by pumping your brakes, so you get a shorter stop time, a shorter stop distance, I should say, because you have static friction. If you didn't have the ABS brakes pumping, human nature, if you see a car in front of you and you slam on a brake, human nature and our brains are not going to say, oh, I don't want to lock my tire, so I'm going to start pumping my brake myself. We don't tend to do that and think that through in the moment of a being very excited and stressed situation. So the brakes do it for you and pump and keep static friction, which gives you the shortest stopping distance. So hopefully you don't hit that car. If you don't have ABS brakes, and if we didn't have ABS brakes on our cars, our human brains are not going to tell us to pump that brake. We're going to lock our tires, and we're going to go to kinetic friction, which is much weaker and will require a longer stopping distance, and then you might hit the car. All right, so that is what ABS brakes do. They take it from kinetic friction of the tires being locked up, pump your brakes, unlock those tires, and restore your static friction, so you have a shorter stopping distance. All right, thank you for watching. I hope this helps explain these. If you've enjoyed these videos, please give us a thumbs up. Please subscribe to us. We would love that. Please share it with your physics peers. If they need help, we would love you to do that and help us get word out. And we're just so thankful that you watched. Appreciate you all, and I know you're going to just crush this whole Unit 6 energy and momentum of rotating systems. We have absolute faith in you, and happy physicsing.